Welcome back, my little lima beans. We are going to talk about our last topic for our prerequisite unit, which is algebraic manipulations and substitutions. So this is not going to be the last time that we're going to talk specifically about math. Once we get into two-dimensional stuff, we're going to have to come back and review a little bit of trigonometry. But this will get us going. This will get us rocking and rolling and ready to do some real grown-up physics. We're going to learn how blocks slide. We're going to learn how cars roll. We're going to learn all sorts of stuff. We're going to learn the inner machinations of the physical world around us, and it's going to be tight. So strap on your bootstraps. We're going to learn about algebraic manipulations and substitutions. For some reason in my brain, algebraic manipulations reminded me of like the Avatar, you feel me? Because he manipulates the elements. So this dude's manipulating math. And that's how I'm going to justify this goofy drawing that I made. But it was fun. I spent way too much time on these little eye things here. But it was a learning experience. And that's what we're here to do. We're here to learn, to test ourselves, to challenge ourselves, and to confront our fears. So let's go ahead and do that. So let's talk about solving equations algebraically. A lot of times in physics, what's going to happen is we're going to need to fight algebra, and maybe not physically like square up with it, but we're going to need to do some algebra without having numbers. And if I know anything about high school students, it's that their three greatest fears in life are being burned to death in a volcano, disappointing their parents, and not having numbers in their algebra problems. So we're going to go ahead and confront the third of those fears today. And we're going to try and move around some equations without numbers, right? We're going to do algebra, not arithmetic, because we're here to face our fears, we're here to learn, and we're here to challenge ourselves. So if I could impart some wisdom unto you before we get started. Hold on, let me just review my slides here. Just kidding. If there are two terms that share a variable, those things are like terms, and they can be added together or subtracted. So what I mean by this is if I have v times t plus v times x. Because these things both have a v in them, they're technically like terms, and we can add them together. You might not think of it as adding together. Maybe we should more think of it as factoring out the v. We could turn this into v of whatever this coefficient of t plus whatever this coefficient of x is. So t plus x. All right. So we can either think of it as factoring out the GCF of v or adding the coefficients of v and x together. However you want to think about it, that's fine. This will come up. I'm kind of teaching you stuff without you knowing the context of it, which might make it seem a little intimidating. But you want to focus on the process today, not what all these letters might represent. Okay, that's maybe the hardest part of physics is when you start dipping your toes in it and you get your foot wet and you dip in the water, you're like, oh my gosh, something just touched my foot and I don't know what it was. Don't worry, I'm not going to let you stick your foot in some nasty swamp with leeches and all sorts of microbial venomous, none of that. We're going to dip our toes in some nice, filtered, safe water. Okay. The next thing I'd like to remind you of is when you're multiplying terms, they don't have to be like terms. So you can take a v and you can multiply it to a t, and it just comes out as vt, all right? You just stick them together. If we have repeated terms though, so let's say we have kx times 1/2 x, we can multiply these together. If we have matching variables, we just add their exponents. So this x and this x match. So x times x would be x squared, And then we just treat this 1/2 and k like coefficients, and we'll have it as 1/2 k. Really, we're just sticking stuff together with like tape. It's not that bad. And I'll make sure we do some examples together so that you don't get too scared. Okay. One of the things that I find most helpful when I'm doing math and I'm trying to manipulate this stuff, instead of focusing, oh no, I don't know what k is. What is k? Is it 12? Is it negative 2.6? Is it 18.9 pi? Don't worry about it. What you want to worry about is what math operation is happening. And then you're going to have to ask yourself, how do you undo that math operation? What's the opposite of it? We're really testing your mastery of algebra and not really worried too much about what the answer is, right? We don't care what the answer is. We care about how do I get there. We're worried about the journey, not the destination. All right, so let's take a look at these three. Actually, I apologize. Let's make a pit stop real quick. Let's talk about this quick note about notation, because I realize that one of those examples has some notation in it that might be a little intimidating. But don't worry, just because the bug's wings look like a predator, it's still a bug, okay? It's not going to kill you. So subscripts are the way that mathematicians and scientists make notes to themselves about a variable, especially if that variable is used redundantly or in more than one spot. So let's talk about a couple of the most common subscripts we're going to see and what they do, and then we'll go back and look at those problems. Okay. The most common two subscripts we will ever see in this class are a 0 and an F. So subscripts are not a math operation. They are a note, okay? These are like little symbols we shove on stuff so that when I say x subscript 0, and the way you would say this out loud is either x not being as like not 0.5. It's the fancy English word for 0. Or you could say x initial like we have here. So if we have a small subscript 0, this 0 is kind of indicating to us t equals 0 or time is 0. This is just saying this is the value of whatever that x variable is representing at the very beginning. So right when whatever we're studying is starting, this is the value of that variable at the beginning. It could be our initial position. It could be our initial velocity. It's whatever it is at the beginning of the problem. If we want to know the beginning, odds are we're doing the problem to figure out where we end up. So x subscript f is said out loud as x final. This is going to tell us the ending value of whatever it is we're studying. It could be x final for our final position. It could be v final for our final velocity, and so on. These are the two most common subscripts we're going to see, and they're pretty useful. Okay, there are way more. You can make up your own subscripts, and just to kind of demonstrate that, we could have capital F subscript n. This is one we'll study and has a special name. This is force normal, or the normal force. Don't worry about what that means yet. It's a fancy word. We'll talk about it when we get there. But instead of saying a time, like the beginning or the end, we can give things names. If I want to say my velocity, I could put v subscript b for velocity of Barton. So these subscripts are names that we get to shove on the bottom of things so that when we see an equation like v final equals v initial plus at, we're using velocity in two spots here, but this velocity is not the same as this velocity. So if we just had v equals v plus at, rather than have us try and just remember that this and this are not talking about the same number, we put subscripts on them so that we can keep them straight. They're literally just notes to yourself to help you keep your math as organized as possible. Okay, now that we have that slight discomfort out of the way, let's go back and look at these really easy, accessible problems. So we want to solve these algebraically. I very intentionally did not give you any numbers and hopefully gave you one to start with that's a little familiar to you. So this, I hope you recognize as the area of a triangle, right? The area of a triangle is 1/2 the base times the height. What we're going to do is we're going to solve this equation for the height. We want, instead of an equation for area, we want an equation for height where I just plug everything else in and it spits the height out for us. So we're going to solve for this h value, meaning we're trying to isolate it. So we need to go back and ask ourselves that all-important question: what math operation is happening here? So this 1/2 and this b, they're being multiplied together. So we need to ask ourselves, what's the opposite of multiplying? If I want to cancel multiply by b, all we have to do is divide both sides by b. Okay, so a divided by b, we don't know what those are, so we cannot simplify them. So we're just going to leave them like that. In a lot of ways, solving algebraically is easier because you go, I don't know what that is, I'm going to leave it that way. So you don't actually do the math, you just set up the math. Okay, equals multiply by b, divide by b, cancels each other out, and we still have 1/2 h. All right. We need to multiply both sides by whatever, or let me back up. We are multiplying by 1/2, so we need to divide by 1/2 here. Unfortunately, you can't really divide by fractions, right? Instead of dividing by 1/2, your math teacher is grimacing right now and they're going, oh, please, anything but that. When we want to divide by a fraction, what we do instead is multiply by its reciprocal. So 2/1. And this kind of harkens back to those unit conversions that we did a couple of lessons ago. This 2 on the bottom cancels this 2 on top. And then these ones, you can think of them as canceling, or you can think of it as ones don't do anything. So we multiplied this side by 2/1. We need to multiply this side by 2/1. 2 times a, we don't know what a is, so that's just 2a. And then 1 times b, 1 times anything is the anything. So we'll just put the b on the bottom. So h is 2 times the area divided by the base. And there we go. We did an algebraic manipulation and you lived. Pause the video, go into whatever room your parents are in and be like, Mom, I lived, and then run out and see what she says. I think that'd be hilarious. All right. You're going to say, all right, Barton, this is an easy problem, though. Don't insult my intelligence. You know and I know that this is going to get way more complicated, and you're just giving me the baby problems because you don't want to really teach me how to do this. I didn't realize I was so transparent. All right, let's do a couple harder problems just to really, you dipped your toe in, let's get the whole foot wet now. We want to solve this equation for v. And this equation is actually our kinetic energy equation. But don't worry about that for right now. It's some random equation and we need to move some letters around. So we're trying to get v by itself. I don't know if anyone has ever told you this before, but when you are solving, you're doing PEMDAS in reverse. So PEMDAS is your order of operations. If you're trying to solve something, you do SADMEP. And you start at the bottom and undo them in reverse order. So we don't have any subtraction or addition. We do have multiplication. We're multiplying by 1/2 and we're multiplying by m. So let's go ahead and undo those. We're going to divide both sides by m. So m divided by m cancels, and we have e divided by m equals 1/2 v squared. Now we need to get rid of this multiply by 1/2. So just like over here, we're going to multiply by the reciprocal because it's a fraction. Let's use that color. So times 2 over 1 times 2 over 1. The 1/2 cancels with the 2. And on the right side, we just have v squared left. Over here, 2 times e is 2e. And then 1 times m is just m. All right. So we took care of subtraction, addition, division, multiplication. Exponents is the next thing we need to get rid of. So we have a v squared. Think to yourself, think back to your Algebra 2 class and ask yourself, what's the opposite of squaring something? Sit, chew on it. Oh yeah, I remember now. It's a square root. So we're going to take a square root of both sides. And you're going to go, oh no, this is so scary. Oh my gosh. Square root and squared cancel. I know that though, Mr. Barton. That's the easy side. What about the other side? Mr. Barton, I have no idea what the square root of 2e over m is. And the short answer is, neither do I. It doesn't matter what they are. We're just undoing the operation and then leaving it for someone else to plug numbers into later. So this just stays the square root of 2e over m. We're just practicing moving stuff. You're not actually going to get a number like 12 or 18 right now. All right, last one. Here's our last big kid one. We're going to solve this bad boy for a. And there's a right there. So if we're trying to get a by itself, there's a lot of stuff going on here. But let's look at PEMDAS and let's slowly approach this in reverse order. Do we have subtraction or addition? Absolutely. We're adding x naught or x initial, and we're adding v naught t. So what's the opposite of adding x naught? Subtracting x naught. So we're going to subtract x naught on both sides. X naught minus x naught is 0. They cancel out. And we're going to have x final minus x naught equals 1/2 a t squared plus v naught t. All right, we're still trying to get this a by itself. So what's the opposite of adding v naught t? Subtracting v naught t. Okay, obviously v initial t minus v initial t is 0. Anything minus itself is 0. Here, these are not like terms, right? X naught is not the same thing as x final. V initial t is not the same thing as x initial or x final. So we just leave them all separate. So we're going to just tack this thing on at the end. So we're going to have x final minus x initial minus v initial t. And then that equals what we have left over here. Equals 1/2 a t squared. All right. That looks like all the addition and subtraction on this side. Now we are to multiplication and division. So what math operation is this 1/2 doing to this a? It's multiplying. So we need to multiply by the reciprocal times 2 over 1 times 2 over 1 on this side. Because I'm multiplying 2 over 1 to this entire side, I have to multiply it to this entire side. You want to put all these adding and subtractings in parentheses, and we'll put 2 over 1 next to it. So this cancels here. You can either leave this as 2 x final minus x initial minus v initial times t, or if the mathematician in you is screaming simplify, we could go ahead and distribute this. So let's go ahead and do that just for fun. So this is 2x final minus 2x initial minus 2v initial t equals a t squared. Now we're at our very last step here. A lot of students are really tempted. They see this squared and they're like, oh, square root, you just taught us that right here. But we need to ask ourselves that question. What math operation is the t squared doing to the a? They're multiplying. So don't take a square root here. We're just going to divide both sides by t squared. Okay. So these cancel, and then we would just leave our answer like this. If we wanted to, we might be able to simplify this t with this t, but then we're going to break our fraction apart. And it's going to get a little messier, so we won't do that. So our answer here is the acceleration is equal to 2x final minus 2x initial minus 2v initial t divided by t squared. And there you go. This is probably far more complicated than what I'm actually going to ask you to do on the homework, but I don't want to be accused of not teaching you or showing you hard enough problems the first time. All right, so that's algebraic manipulations. That's how we're going to rearrange stuff. A lot of times you're going to be able to plug in numbers and avoid this, but it's fun. It's a good thing to get in the habit of doing, especially if you want to continue a career in math or physics or engineering. This is a necessary skill if you're planning on going into like a really rigorous STEM field. So, you know, we might as well dip our toes and get them wet and start the process now. All right. Last topic we need to talk about today are substitution and combination functions. And it sounds scarier than it is. If you're in my pre-calc class or in my algebra class, you probably are doing this right now. It's not a super complicated idea. The idea is we're going to plug one function into another. So usually in physics, you don't just have an equation, x equals v times t plus x initial. And you probably don't just know enough information to plug it right in, right? Usually in physics, we're going to have to use two or more equations to get the answer that we want. But that is going to involve solving a system of equations. That's why you learn that in algebra. So what we're going to do is we're going to just go over how do I use substitution. And I feel bad not telling you the true name of composition function, so it's there. But don't let it intimidate you. So we're going to practice taking one function, substituting it into whatever variable it's equal to, and then simplifying and solving for something else. Okay, I have a couple easy examples, and we'll let the hard stuff come up later as it's required. We're not going to go too crazy today. All right, so let's look at these two examples. We have f equals ma, and we'll learn this is a very important equation for later, and f equals negative kx. So what we're going to do is we're going to substitute ma into f, because ma equals f. So anywhere we see an f, we can replace it with ma. So we're going to have ma equals negative kx. Now we want to solve for x. We want to get x by itself. So we ask ourselves that question, what math operation is this negative k doing to the x? Because they're just sitting right next to each other like friends, they're multiplying. So what we have to do to get rid of this negative k is divide both sides by negative k. So these cancel, and we have ma divided by negative k equals x. And we're done. What a question like this could be a question on its own on the AP test. It'll say something like solve for x in terms of mass, acceleration, and whatever k is, and k. So you'll say, oh, well, I know f equals negative kx, but I'm not allowed to have this f in my equation. The question doesn't say in terms of f, it says in terms of these other things. So you just have to substitute that for whatever the other things are equal to, and then isolate the variable they're asking for. This exact type of problem will show up on your AP test. All right, let's do one more. It says 0 equals f sub n minus f sub g, and f sub g equals mg. So what we're going to do is we're going to plug in fg there. So we're going to substitute in m times g. Then we're going to isolate fn. So let's go ahead and do the substitution first. 0 equals, we don't have anything that fn equals, so we're just going to leave it as fn. Minus where the fg was. I like to put parentheses just to make sure I don't goof up any signs or anything. Plug that whole thing in there, mg. Now it says solve for fn, so we need to isolate this variable. So we ask ourselves, what math operation is the mg doing to the fn? It's subtracting, so we need to do the inverse math operation, or the opposite. So we're going to add mg on both sides. Negative mg plus mg cancels. So on the right side, we just have our normal force left, or Fn. On the left side, 0 plus anything. If you have nothing and you add something to it, all you have is that something, right? Nothing plus something is just the something. It's not like 2 something or something and a little bit. It's just the something. So it's mg. And there we go. So Fn equals mg in this case. All right. I understand that this might be a little bit obtuse just because we're using a whole bunch of crazy physics variables. What is Fn? What is m? What is g? Don't worry about what they represent right now. All you're worried about is, can I move these weird symbols around by following the rules of algebra? Can I do inverse math operations? Can I do PEMDAS backwards? Can I stay calm? Later, I like to give students lists of maybe steps to follow, and they're more like guidelines. But on most of those lists, I start with step 0 every single time, and step 0 is stay calm. You are doing probably one of the most challenging subjects right now. So if you feel a teeny tiny bit overwhelmed, don't worry. I'm here to hold your hand. We're going to take it one step at a time, and we're going to have fun. This is tight. This really tickles that itch in the back of my brain. You know what I mean? So maybe I'm a little weird, but you know, I think all physics teachers are a tiny bit weird, but that's fine. So before I conclude this video, if you're ready for the homework, you can pause the video and stop. Everything from here on out is me storytelling, but you know, let me tell you a short story for encouragement. These two gentlemen, you probably recognize this dude here. This is the Albert Einstein. And he is the dude who, I don't want to say discovered, but he wrote the equations for this really sweet thing called general relativity. And Albert Einstein, I think, is probably the most recognizable scientist to have ever lived. The fact that you have no idea who this dude is kind of illustrates my point. This could be Watson from Watson and Crick, who did DNA. It could be Fermi. It could be Niels Bohr. You have no idea, right? But you definitely know Einstein, right? And a lot of people like to say that Einstein was the most intelligent human being to ever live. So let me tell you a little story about Einstein and this guy. This guy is named David Hilbert. And Hilbert was not even really a physicist. Okay, David Hilbert was a math guy. And Einstein, while he was working on his theory of general relativity, David Hilbert said, wow, that looks really, really interesting. I think I'm going to give it a go. I'm going to solve general relativity, because David Hilbert was actually a very smug individual. He is on record saying that physicists are too dumb to do physics. And I'm paraphrasing a bit, but this guy had the gall to say physicists are too stupid. And I might be being a little bit belligerent here, but they're too dumb to do physics. Physics is way too important for humans to be left to these morons, this guy, to figure it out. They're too bad at math. And while there may be a teeny tiny bit of truth to what he was saying, Einstein, and you have no idea who David Hilbert is, right? So I think that goes to say how credible that accusation is. But David Hilbert started working on this problem of general relativity, and he sent Einstein some letters and said, you know what, Einstein, this problem's not even that bad. I've been working on it for a couple of weeks, and I think I'm pretty close to a solution. And he sent some preliminary notes to Einstein. Einstein had been working on this problem for 5 years at this point, and David Hilbert, in the matter of a month or so, covered as much ground on the problem as Einstein did in something like 2 years. So Einstein starts sweating bullets. Hang on, that's not very good sweat. Right? This dude starts sweating. He's like, oh no, right? Sad anime face or whatever. He's like, oh no, this guy, he's going to finish the problem that I'm trying to stake my claim to fame on before I even finish it. And I had a 5-year head start. And David Hilbert got incredibly close. For a while, historians thought that Einstein literally stole credit from David Hilbert, and that Einstein plagiarized this guy and didn't actually solve general relativity itself. Some say that Hilbert did it first, and then Einstein, just because he had been working on it and making a lot of commotion in the community, people are like, oh, Einstein got it, this Hilbert guy must have copied off him, right? And just because of who Einstein was, they made the assumption it went this way. I think later they verified that Einstein had a really, really important step that Hilbert was missing. And without that step, general relativity is bogus. So they said, you know what, Hilbert, beat it, nerd. You didn't do it. So I think Einstein actually did discover general relativity. But Hilbert came in, swooped in, almost stole the most famous thing ever from him. And what I'm trying to get at here is you're following in their footsteps, and you're doing a very challenging subject. If the most famous, intelligent scientist who ever lived was scared out of his wits because some math dude came in and was like, check me out, and he's just like, lol, 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 math go burr, it's normal to be a little bit intimidated by math. Math is challenging, and it's what makes physics hard and rewarding to do. So if at this point in the class you're like, Mr. Barn, I'm in the prerequisites, and this what in tarnation are you trying to, what is this? Calm down, okay? Einstein had issues doing math. This is normal. These are growing pains. Eventually, you're going to be a physics teacher in a high school classroom someday, just like me, and then you're going to just whip this stuff out, and then kids are going to be like, oh my gosh, you're a math warlock. And you're going to be like, it's you're right, I am, but I'm tooting my own horn a little bit at this point. But struggling with math is normal. Physics is one of the most challenging subjects that you can study. I believe studies show that if you give students at universities IQ tests, the people who consistently score in the top 2 or 3 are mathematicians and physics students. It's just the nature of how A, IQ tests are written, and B, how kind of challenging it is. If it's hard for you, I will say that the most important thing to growth and learning is not IQ. Okay, IQ is maybe down here at like number 4, right? The most important part to learning and doing challenging things, and this isn't just math and physics, this is art, this is music, this is gardening, this is showing up to work every day. The most important thing for being successful is determination. Okay. Einstein worked on his theory for over 5 years and almost had it stolen by this joker. But he persevered. He stayed determined. He kept working on it, and he didn't let this demoralize him. He said, no, I'm going to crack this. And it was his determination that pulled him through. Obviously not his IQ, because Hilbert was better at math. So don't worry about it if the math is a little stressful. What's important is that you say, no way, I'm not going to let this beat me. I'm determined, and I'm going to make it through. So now that we've talked about life lessons with Mr. Barton, go ahead, rejoin the WebEx. I'll open up your homework. You'll get to practice on your very own challenging problems with a whole bunch of math and letters that you don't understand yet, but that's part of the process. Make sure you like and subscribe. I'll see you guys next time.